Hello, geometry crew. We are going to do a video right now on how do you use the fact that you know something is a parallelogram to help you prove other stuff. All right, so the nice thing about these proofs is that if you know something's a parallelogram, you know lots of things about that without having to do a lot of work. So it's really beneficial when something comes right out and says, hey, this thing's a parallelogram. Now prove other stuff. And let me show you what I mean. So we are working on this lesson, proving triangles using parallelograms, Unit 6 and Day 6. And I'm just going to jump right in. So this says, given ABCD is a parallelogram, prove that the top triangle, this thing up here, is congruent to the bottom triangle, that thing down there. Okay, I think I can do that. Well, if I'm going to prove triangles congruent, I have 5 different congruency theorems I can use. SAS, ASA, AAS, SSS, and HL. So long story short, I need to find a bunch of sides and or angles that I know are congruent. And the only thing they told me was ABCD is a parallelogram. But when I say only, that's a big thing. If ABCD is a parallelogram, I automatically know that AB is congruent to CD and BC is congruent to 80. I got 2 sides right off the bat. So I'm going to say AB is congruent to CD, and I'm going to say BC is congruent to AD. And how do I know that? Well, I know that because it's a parallelogram, and parallelograms have congruent opposite sides. So we are going to say opposite sides of a parallelogram are congruent. Awesome. And actually, while we're on the sidekick, I know that AC is shared by both triangles, so I can use the reflexive property. AC is congruent to AC. Reflexive property. And now I'm done. I mean, I have all 3 sides of both triangles, so I know triangle ABC is congruent to CDA by SSS. I mean, that's it. That's SS congruence, and I'm done. That wasn't so bad, right? All right, let's come down here. Given ABC is a parallelogram, prove BEA is congruent to DEC. Okay, I think we can do this too. Well, let's start the same way we started before. If I have a parallelogram, I know that opposite sides are congruent, but in this picture, the really only ones I need are that AB and CD are congruent. So I'm going to run with that. AB is congruent to CD because opposite sides of a parallelogram are congruent. Now, there's like 6 different things I could do next, but I'm going to go somewhere that I just feel like going so I can teach you something. One of the other things that we know about parallelograms is not only are their opposite sides congruent, but their opposite sides are parallel. So I'm going to say that too. I'm going to say that AB is parallel to CD because opposite sides of a parallelogram are parallel. And why is that helpful? Well, parallelism usually leads us to some congruent corresponding and or alternate interior angles. And in this case, it's going to lead to some alternate interior angles because if I were to like trace this line and then that diagonal and then this line, there's a pair of alternate interiors right in here. I could say that angle ABE is congruent to angle CDE because parallel lines create congruent alternate, my face is in the way. Move, face. Congruent alternate interior angles. And as a matter of fact, I can do that using the other diagonal as well. And I would have this one and that one. And since it's the same reason, I'm going to put it on the same line. Angle BAC is congruent to angle ACD. And then when I look at my picture, I realize I have 2 angles and the side in between. I have ASA. So for step 5, I'm going to now say that BEA is congruent to DEC by ASA. Not bad at all. Is that the only way to do this? No, absolutely not. There are so many more. If I'm looking at this, in about the same amount of steps, I could have done this using ASA. I could have done this using SAS. I could have done it using AAS. And I could have used it doing SSS. Okay, there are lots of ways for this one to go. I just picked this way so that we could talk about what can you use that parallelism for. Okay, so number 3. Fun fact. In number 3, I forgot to give you a piece of information and the diagram is cut off. So instead of making this video longer and giving you more information, I'm just going to say we are going to skip number 3. If you wanted to try and do some practice, you could rewrite this as B, C, and E, G. And then you're going to also add a given condition that I is the midpoint of EF. But I'm going to skip that for now. Okay, so we are going to move on to number 4, and then that'll be the last lesson for this video, this last proof. All right, so number 4, given ABCD is a parallelogram. Cool. BE is perpendicular to AD. Okay, so that would make that a right angle. And FD is perpendicular to BC. Okay, that would make that a right angle. Prove that ABE, this thing is congruent to that little thing. Okay. Why would they ask me to prove angles congruent? Oh, remember that CPCTC thing from the last unit? If you're asked to prove that two angles are congruent, there's a good chance that what you can probably do is prove the triangle is congruent. And then use CPCTC to say the angles are congruent. So I'm going to put in an additional prove condition here that I probably want to prove that triangle ABE is congruent to triangle CDF, and then prove that those angles are equal. That's what I'm thinking I want to do. All right, so given that it's a parallelogram, what am I going to do next? Well, just like in the last one, if I've got a parallelogram, opposite sides are congruent. So I know that these two things are congruent. Awesome. So AB is going to be congruent to CD because opposite sides of a parallelogram are congruent. Fine. Let's see. What else can I do with this? You know what else I can do with this? I can say opposite angles of a parallelogram are congruent because isn't angle A and angle C, aren't those opposite angles? They sure are. So angle A is congruent to angle C because opposite angles of a parallelogram are congruent. All right, and then that's about the properties of a parallelogram I can use right now. The other thing they gave me in the given was that perpendicularity. So I'm going to remember that perpendicularity leads to 2 steps. Identify the right angles and then say that they're congruent. So I'm going to say angle AEB and angle DFC are right angles because perpendicular lines form right angles. And then I'm going to say that they're congruent because all right angles are congruent. And then if I look at those two triangles, yeah, I see angle, angle, side. I see AAS. So I now know that triangle ABE is congruent to triangle CDF by AAS. And once I have AAS, I can use CPCTC. Angle ABE is congruent to CDF by CPCTC. Cool, cool. All right, I'm done. So hopefully that made some sense to you. And we are done with this lesson. There's not even any homework that follows. So learn something, let it sink in, and have a great day.